Gold, the eternal metal, has captivated humanity for millennia. Its allure lies in its rarity, beauty, and enduring value. For centuries, prospectors have scoured the Earth's surface seeking signs of this precious metal. The discovery of a gold deposit can transform fortunes, fuel economies, and leave an enduring legacy on the landscape. Yet finding gold is no easy feat. Gold deposits are often hidden beneath layers of rock, sediment, and vegetation, concealed from the naked eye. Traditional prospecting methods, relying on visual cues like quartz veins or panning for gold flakes in streams, are often insufficient to locate these buried treasures. This is where geochemical exploration comes into play, utilizing the subtle chemical clues that gold leaves behind. Geochemical surveys analyze the composition of soil, rocks, and water to detect the presence of trace elements associated with gold mineralization. These elements, often present in minute quantities, act as invisible breadcrumbs, leading explorers towards potential gold deposits. However, interpreting geochemical data can be complex. The Earth's crust is a heterogeneous mixture of elements, and simply identifying the presence of gold-related elements doesn't guarantee the existence of an economically viable deposit. This is where the gradient method emerges as a powerful tool, enabling geologists to see beyond the noise of background geochemical variations and focus on the subtle gradients that often betray the presence of hidden gold deposits. Traditional geochemical exploration often relies on identifying areas with high concentrations of gold or its associated pathfinder elements. While this approach can be effective, it often overlooks subtle variations in element distribution that can be crucial in locating hidden deposits. The gradient method offers a fresh perspective, shifting the focus from absolute values to the rate of change in element concentrations. Imagine a gentle slope leading up to a hidden treasure chest. Simply looking for the highest point on the slope might not lead you directly to the treasure. Instead, by observing the gradual increase in elevation, the gradient, you can trace the slope back to its source, ultimately uncovering the hidden riches. Similarly, the gradient method in geochemical exploration involves analyzing the spatial distribution of element concentrations and identifying areas with significant changes or gradients in those concentrations. These gradients often occur at the edges of mineralized zones, where the interaction between mineralizing fluids and the surrounding rocks creates distinct geochemical signatures. By mapping these gradients, geologists can delineate potential ore zones, even when the absolute concentrations of pathfinder elements are relatively low. This approach proves particularly valuable in areas with subtle geochemical anomalies or where traditional methods have failed to yield promising results. The gradient method's effectiveness stems from its ability to amplify subtle variations in geochemical data, revealing hidden patterns that would otherwise remain obscured. By embracing the concept of gradients, exploration teams can enhance their understanding of the geochemical landscape and increase their chances of uncovering concealed gold deposits. To grasp the power of the gradient method, let's consider a hypothetical gold exploration project. Imagine a team of geologists exploring a remote region with known gold occurrences. They conduct a soil geochemical survey, collecting samples at regular intervals along a grid pattern. Initial analysis of the absolute concentrations of gold in the soil samples reveals no significant anomalies. The gold values seem randomly scattered, offering no clear indication of a potential deposit. However, when the gradient method is applied, a different picture emerges. By calculating and mapping the gradients of gold concentrations between adjacent sample points, the team identifies distinct zones with high gradients. These zones, characterized by rapid changes in gold values over short distances, form linear trends that cut across the otherwise random distribution. Further investigation reveals that these high-gradient zones coincide with subtle topographic features and geological structures known to be favorable for gold mineralization. Encouraged by these findings, the team focuses its exploration efforts on these target areas, ultimately leading to the discovery of a previously unknown gold deposit. This example illustrates how the gradient method can unlock hidden value in geochemical data, revealing subtle patterns and guiding exploration efforts towards promising targets. By looking beyond absolute values and embracing the concept of gradients, geologists can enhance their ability to find gold and other mineral deposits, even in challenging geological environments. While specialized software exists for geochemical data analysis, the gradient method can be implemented using widely accessible tools like Microsoft Excel. This section provides a step-by-step guide to performing gradient analysis in Excel, empowering geologists with a simple yet powerful tool for gold exploration. First, organize your data. Input your geochemical data into an Excel spreadsheet with sample locations, such as easting and northing coordinates and corresponding element concentrations. Next, calculate the gradients. For each pair of adjacent sample points, calculate the difference in element concentration and divide it by the distance between the points. This represents the gradient of element concentration between those 2 points. Repeat this process for all adjacent sample pairs. Then, create a gradient map. Use Excel's conditional formatting or charting features to visualize the calculated gradients. Assign different colors or shading to represent varying gradient magnitudes, highlighting areas with high gradients. After that, overlay with other datasets. Import and overlay other relevant datasets such as geological maps, topographic maps, or geophysical survey results to identify correlations between high gradient zones and favorable geological features. Finally, interpret the results. Analyze the gradient map in conjunction with other datasets to identify potential target areas for further exploration. Focus on zones with high gradients that coincide with favorable geological settings. By following these steps, geologists can effectively apply the gradient method using Excel, enabling them to analyze geochemical data, identify subtle patterns, and pinpoint potential gold deposits. This accessible approach empowers exploration teams of all sizes to leverage the power of gradients in their quest for gold.
Welcome to the world of geology and earth sciences with Ricardo Valls, a seasoned professional geologist bringing you over 1,500 videos of unparalleled expertise. Whether you're a budding graduate student, an early career specialist, or a seasoned professional, this channel is your gateway to a wealth of knowledge. Explore a vast array of Earth-related subjects, including geology, geochemistry, structural geology, and the application of artificial intelligence and machine learning in geosciences. Ricardo Valls not only shares his own invaluable insights, but also brings you exclusive interviews and collaborations with other prominent geologists, offering a comprehensive view of the field. Stay ahead of the curve with our latest content, covering everything from unraveling the Earth's secrets to exploring global geological phenomena. Don't miss this opportunity to enhance your knowledge and stay at the forefront of the industry. Subscribe now, hit that like button, and share this invaluable resource with your colleagues and friends. Join our growing community of over 2,000 earth science enthusiasts and professionals today. Unlock the secrets of the Earth with Ricardo Valls, your top resource for all things geology. The future of geosciences is here. Be part of it.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.